Good day, ladies and gentlemen. I'm discussing experiment 3 and I'm giving you some background information to enable you to understand the experiment and also answer the questions on Blackboard. This experiment is about transition metals reacting with gases containing sulfur. In inorganic 2, we have classified reactions according to 3 classifications. We have spoken about precipitation reactions, redox reactions, as well as neutralization reactions. In these experiments, we will be looking at precipitation, redox, and some reactions which can be classified in 2 groups. So those reactions are a combination of the two, so that reactions can be a precipitation as well as a redox reaction. If you have forgotten how this classification works, please consult McMurray and Fay to refresh your minds. But in short, a precipitation reaction can be recognized by having 2 soluble reagents which react with each other, forming a insoluble product. A redox reaction can be recognized by looking at the elements' oxidation states. So the one element will have a reduction in its oxidation state and the other element will have a increase in the oxidation state. So when you have a reduction in oxidation states, it is reduction. If you have an increase in your oxidation state, it's oxidation. Oxidation and reduction happens in pairs, or it happens together because the one reaction is producing electrons and the other reaction is using those same electrons. And that's why we are talking about a redox reaction. Then we still have a combination of the two. That means this reaction is classified both precipitation and redox, which means in this particular reaction you will see a change of oxidation states as well as some solids, some precipitates forming. Hydrogen sulfide and sulfur dioxide can act as reducing agents, and over here you can see the half reactions for those 2 sulfur-containing gases. When you look at this half reaction, you will see that the sulfur in sulfur dioxide has an oxidation state of +4. If you calculate the oxidation state of sulfur in the sulfate anion, you will find that the oxidation state is 6. So our sulfur's oxidation state has moved from +4 to +6, which means it's moved from 4 to 6. That's an increase in the oxidation number, which means the sulfur has been oxidized. So it means the sulfur has lost 2 electrons. So these 2 electrons are therefore available to react with something else. And in this experiment, it will be reacting with your transition metals, causing a reduction of those transition metals. Let's look at the half reaction of hydrogen sulfide. Now, in this case, we are assuming hydrogen to be +1, so therefore our sulfur has an oxidation state of -2. Over here we have sulfur as an element, and it means that our sulfur has an oxidation state of 0. So our oxidation state has changed from -2 to 0. So that's an increase in the oxidation state, which means the sulfur has been oxidized. During this oxidation process, 2 electrons have been formed, and these 2 electrons are therefore available to reduce your transition metal. Okay, let's look at the products forming. Here you have a sulfate anion. It's soluble. Here you have some protons. It's soluble. Those 2 electrons will be consumed in the other half reaction. So everything in this half reaction is soluble. Let's look at this other half reaction with hydrogen sulfide. You're forming sulfur, which is insoluble, which means reactions with H2S, you're expecting some precipitates. So in this half reaction, we have a change in oxidation state, which means we have a redox reaction, and we have a soluble gas forming a insoluble product, which is your sulfur. So which means it will also be a precipitation reaction. So, as you can read here, that you expect a yellow precipitate of sulfur when using hydrogen sulfide as your reducing agent. Now, sometimes hydrogen sulfide does not act as a reducing agent, but rather causing the formation of a metal sulfide. So when hydrogen sulfide reacts with manganese, nickel, and cobalt, the sulfides are formed. Manganese sulfide, cobalt sulfide, and nickel sulfide. But now often these metal sulfides are soluble in acidic solution. So it means they are not precipitating. And to cause them to precipitate means you need to change the pH, changing it that it's not acidic any longer. And to make a solution not acidic, changing it to basic, you have to add some base. You can either add ammonium hydroxide or sodium hydroxide. So then your pH increases from acidic to higher than 7, which is basic. So in short, these manganese sulfide, cobalt sulfide, and nickel sulfide will not form a precipitate in an acidic medium because they are soluble. You need to change the pH. You have to increase the pH to make your solution basic, and then these metal sulfides will become insoluble, and they will form a precipitate. So here we just have manganese oxide. So you can also calculate the oxidation state. So this is not a peroxide or a superoxide, so which means the oxygen's got a oxidation state of -2, but we have 7 of them, so 7 times -2. Manganese is unknown, so it's 2 times x because there's a subscript 2. So 2 times x plus 7 times -2, and you can solve for x, and then x is 7. So in this particular manganese oxide, the manganese has got an oxidation state of +7. So now you can calculate the oxidation state of manganese over here, and you will find it to be 7. And here we have the manganese oxidation state of +2, so we will have a reduction of our manganese.